Hi guys, so part 2 of esters. I've just changed the learning intentions around, so I've put the hydrolysis stuff from the previous video just as question number 5. So part 2, we're going to be looking at fats and oils, and then a thing called saponification. All right, so let's start off with fats and oils. So animal fats and vegetable oils are naturally occurring esters called triglycerides. Now, they are essentially triesters. Now, we know the word tri means 3. So let's have a look at what they are. So here is a molecule called glycerol. In fact, what it is 1, 2, 3. So that's prop. It's propan 1, 2, 3 triol. Okay, that's its technical name. But glycerol is another name for it. If you combine an alcohol and a carboxylic acid, you get an ester. Okay, if you get an alcohol and a carboxylic acid, you get an ester. Or if you do a triol, okay, so it has 3 alcohol functional groups, and you add a carboxylic acid to each of those parts there, you get a triester. And a triester is a fat or an oil. Okay, oils are liquids at room temperature, fats are solid at room temperature. So the key part there is it's no different. Just because it looks kind of technical, it looks a bit, a little bit scary, it's quite a big structure, it's no different to the formation we've seen before. Carboxylic acid plus alcohol forms ester. It just happens to be that this molecule has 3 parts of it attached. Here's another example. So glycerol, okay, it always starts with the main, with glycerol, which is this triol, 3 alcohol functional groups, and different fats and oils have different carboxylic acids bonded to it. Okay, so this particular one has got stearic acid to it, but if you were to change, you could have a different carboxylic acid here, another one different there, another one different there. So the combinations are almost endless. So fats and oils can be completely different. Okay, so that's how the formation of it. Now, the main questions in exams are around hydrolysis. So we've just learned about hydrolysis, the splitting of the ester functional group using water. So it is no different for splitting the functional group of fats and oils. Okay, the split happens in this position, this position here, and this position here, and it goes and forms the same products as before. So acid hydrolysis is going to form carboxylic acids and the alcohol. Base hydrolysis, if we were to split this, if we were to hydrolyze this using a base, we would form the alcohol, and we would form the carboxylate ions. So we would be that exact product, but without the H, and it would have a minus. That exact product without the H and the minus. That exact product without the H and the minus. Acid and base hydrolysis is very similar. Let's look at it more specifically and how it's important. So let's go back to our learning objectives. Explain what fats and oils are. They are triesters. Okay, they are triesters. That's as simple as they are. Now we want to explain saponification. So let's go back. Saponification. What a technical word, eh? Let's see what it means. Saponification is the formation or making of soaps. Okay, making of soaps. Now, I want you to think back to when in year 9, 10, 11, 12, when you've used sodium hydroxide. Now, you probably don't remember, but if we were in class, I would ask for a volunteer and say, all right, who's going to let me pour this chemical on their hand? And sodium hydroxide, I would pour it on their fingertip. Now, when you pour that on, it starts to feel slippery and soapy. The reason is that you're actually forming a soap. How are soaps formed? You get a triester, a fat or an oil. And guess what your skin is covered in? Your skin is covered in oil. If you do base hydrolysis with sodium hydroxide, you do hydrolysis and you form the triol, the thing we started with, and you form this, your carboxylate ion, but with a sodium attached. This is soap. So if you were to pour some sodium hydroxide on your finger, it's going to react with the oils in your finger and it's going to form soap. So what is a soap? A soap is a carboxylate or a sodium carboxylate. Okay, a sodium salt. The carboxylic acid part here is a fatty acid. That's what's essentially the oils in your body are made up of. Fatty acids that are then turned into oils. So we're doing the reverse of that. This here, carboxylate salt, okay, with sodium. That is a soap. Let's look at some exam questions. Okay, 2016. Triglyceride found in olive oil has the following structure. Here is our triol, okay, splitting between these oxygens here. Here is our triol, and then this is a carboxylic acid, this is a carboxylic acid, this is a carboxylic acid. So the questions are pretty easy. Put a circle around one of the ester groups. There it is there. Great, done. Nice and simple. Got ourselves an achieve mark. Draw the structural formula of the products produced when the hydrolysis of this triglyceride in basic conditions using sodium hydroxide. So the skill here is knowing that it splits between these oxygens here, and your products are going to be this triol. Okay, you would have to draw that out, just taking off this part, taking off this part, taking off this part, and putting an H in the end. And then each of these is a separate product. Now you'll see this one and this one are the same as each other. Okay, so the carboxylate, because it's base hydrolysis, we're going to form a carboxylate ion. The carboxylate ion there and there is the same. However, this one is different. So you're going to get your triol as one product, this carboxylate ion as a second product, and then this as a third product. So let's have a look at that over here. Here is our triol. Here is the sodium carboxylate. So that is soap, and that is also soap. So these two make that one, and then this one makes this. So that's not a too bad question, really. Let's have a look at 2015. Same sort of thing. This one says circle one of the alkene groups. So here is an alkene group. So again, it's just checking your understanding. But now it's brought in a thing called triglycerides described as unsaturated. This is no different to your understanding of saturation and unsaturation previously. Remind ourselves right back to the start of year 12, organic chemistry. A saturated hydrocarbon is one that contains only carbon-to-carbon single bonds. Okay? Saturated. Unsaturated means there is at least one carbon-to-carbon double bond. Okay? So this question. Describe a chemical test that can be used to show that the molecule is unsaturated. Give any observations. This is a year 12 question. Okay? Test for unsaturation is using bromine water. If you got this molecule here, this triglyceride, this oil, and we added orange bromine water to it, the bromine would do an addition reaction here and addition reaction here, adding bromine, and would decolorize your orange bromine water. Okay, so even though this is a fat and oil, we're not going to learn specifically about doing this test for unsaturation. It's expecting you to combine your knowledge about this and something that you've known previously. All right, here is our more familiar question from what we've just been talking about. Draw the structural formula of the organic products formed by hydrolysis of this, and again, it's using sodium hydroxide, so base hydrolysis. Base hydrolysis, we're going to get an alcohol and the sodium carboxylate ions. Let's have a look. So we're going to split down here. Here is our triol. Okay. Here is one carboxylate ion. This is the same as the one above, and then this one is a different one. Very similar to that previous question. 2 years in a row. Very similar. Here are our answers. Here is the triol. Here is one of the sodium carboxylate ions. Here is the other sodium carboxylate ions. So these two are soaps. Question's not asking you about soaps, but it's important to know because they may ask about soaps. Okay, I hope that helped, guys. There will be some questions attached with this. Thanks. Bye.